Now that we have covered attributes, entities, and relationships, we need to talk about cardinality constraints. So, cardinality constraints will specify the number of instances of one entity type that can be associated with another instance in the relationship or from the other entity in the relationship. First of all, we'll talk about maximum cardinality, which is the maximum number of instances that can be in a relationship. And we will have three types of cardinality in this case. We'll have one to one to many, and many to many. So one to one says each entity instance in the relationship will have exactly another related instance from the other entity type on the relationship. On the other hand, one to many will say that an entity instance on one side of the relationship can have many entity instances, while the other side of the relationship, which is the many side, will have only one instance. And the final case, when we have a many to many relationship, that means entities on both sides of the relationship can have many related instances on the other side. So we'll have some representations or some notations to represent those um, cardinality constraints. So we'll start with the single relationship, which is represented by a bar, multiple relationship, which will be represented by the crowfoot. Later on, when we talk about minimum cardinality, we will also talk about those two, which is the optional or the mandatory. So let's talk first about one-to-one relationship. Let's see an example. So if we say each employee is given a parking space and each parking space is assigned to one employee only, that means we will have two entities, namely employee and parking space. So let me just say E will represent employee in this case, and parking space will represent, or P will represent parking space in this case. So the easiest way to figure this out is when I say, okay, from employee to parking space, how many do I have? The answer is one. And from parking space to employee, how many do I have? Then the answer is also one. So in this case, one translates to this notation, which is the bar. And in this case, this translates to this notation, which is the bar. So when I'm going from employee entity to parking entity, I will place a bar. When I'm going from parking entity to employee entity, I will place a bar as well. And this is the end diagram that I'll have. So I'll say, okay, each entity is assigned parking space, and the parking space is assigned to one employee. Now, when you are reading, you will read the notation that's further away from the entity that you're starting with. So if I'm starting with employee, I will ignore the first one right here and I will read the other one on the other side. Similarly, if I'm reading from parking space and going this way, I will not care about this. So this will be ignored when I'm reading, just when I'm reading, and I will be reading this. So I'll say each parking space is assigned to one employee. And when reading those types of figures or types of business rules, when extracting the business rules from those figures, we have to read it both ways. So this way and this way. The reason is we have two sides of the cardinality constraint. So if I'm reading left to right, I will read this. If I'm reading right to left, I will read this. So that's why I have to have two business rules for each one of those. Now let's look at another example, the case of one-to-many relationship. So I say a product line contains many products, and a product belongs to only one product line. So let's try to analyze this and try to draw the part of the ERD. So I will say, okay, I will have product line denoted by PL for now, and I will have P for product. So if I'm going from product line to P, I need to know what cardinality, and if I'm going from P to PL, I need to know what cardinality do I have in that case. Okay. Now we say a product line contains many products. So it says, okay, when I'm going from product line to product, I have a many situation. So I'll say, okay, this is many, and this will translate to the many notation, which is the Crawford. Now, from product to product line, a product belongs to only one product line. I'm starting with product, ending with product line. So when I'm starting with product, ending with product line, it says only one. So in this case, I have cardinality of 1, and this is going to result in this notation. So when I draw this, I will have product line, and if I'm going from product line to product, as I analyze, I will have the Crawford in here. And if I'm going from product to product line, we said we'll have just a bar, and this should be my final ERD. Now similarly, we'll do the same for many to many, and we'll say, we'll have this example. A student registers for many courses, and the course can have many students. So in this case, we will just do this again, and we'll say, okay, I'll have two entities in this case. Let me just, for simplicity, say S and C. Now when you're drawing, you will not give your final answer in terms of S and C, because remember, from the guidelines of naming entities, this is a bad thing, but I'm doing this just to save a little bit of time. So from S to C, which is from student to course, and then from course to student. So when I'm reading from student to course, a student registers for many courses. So this is going to be a mini relationship that is translated to this notation. And from course to student, I also have many relationship. So I will say, okay, this is again is a many relationship that translates to this notation. My final drawing will be student, which I'll just say S for now, and course, and then I'll have many here and many here. So my really final ERD is going to be something like this. Now keep in mind that you will have to write what the relationship is. Now I didn't include it in this analysis here, but I will have to include it at the end, because you have to tell me what this relationship is. Now you don't have to put it both ways. It's always better to have to put it both ways to make it easier to read. So I can say something like can have here, and this is going to be even better, because when you're reading from left to right, you're reading whatever label is on top of the relationship line, and when we are reading from right to left, we read the label that's on the bottom, okay, or below the relationship line. Now again, we don't have to specify both. Specifying the one that's on top will allow us to know what is the other one or what's on the bottom, because you can just figure it out. If a student registers for multiple courses, then the course can have multiple students. Again, it's always better to include this, but it's not necessarily, as we can infer it from the top one. Okay. Now let's describe the business rules. Now we're drawing the ERD based on the business rules. Now another sort of questions is giving this sort of ERD, you have to give the business rules out of this. First of all, how many business rules we are going to have in this situation? For each relationship, you will have two business roles. So in this case, I have two relationships. The first one being works in, and the second one being is assigned. So I'll have two business rules for this top one and two business rules for this bottom one. Now let's try to read this. Now we'll say, okay, each employee works in one department, because remember, when I'm reading from left to right, for example, so I'm reading this from left to right, going from employee to department, I will not read this part in this case. I will just focus on this one, which is the further away from the entity I'm starting with. So I'm starting with employee, the further away is this cardinality constraint. So I will go and read it like this. An employee works in one department. And if I'm reading from the department side, so this is one business rule right now. I need the other business rule. So I need to start reading from department. And when I'm reading from department, I will not read it as works in, because department does not work in employee. So I will just have a label here. I don't have to draw the label, but I will infer the relationship based on the top one, and I will say, okay, if employees work in the department, then the department can have multiple employees. So I can just say, okay, what I infer here is something like can have, and I will read it like this. The department, remember we're ignoring this, can have multiple employees. So these are the two relationships for this part. And then similarly, I will say, okay, from employees to tasks, I will say employee or an employee is assigned multiple tasks, and a task is assigned to multiple employees. Okay, now when you are reading, you read a singular instance from the entity type you're starting with, and then based on the cardinality constraint, you'll know whether the other one is singular or plural. So you don't say departments have multiple employees. No, we'll say a department can have multiple employees, and in this case, an employee works in one department. Similarly, for this case, an employee is assigned multiple tasks, and a task is assigned to multiple employees. And these are the business rules we just extracted from this ERD. Let's have just two more examples. So draw the ERD based on the following business rule. This is a typical question that you might face. So a student lives in one dorm, and the dorm can have multiple students. Again, the easiest way is to analyze the problem that we have. So I have two cardinalities for this relationship. So if I'm going from student side to dorm side, and if I'm going from dorm side to student side, then what are my constraints? So if I'm going from student side to dorm side, it says a student lives in one dorm. So if I'm going from student to dorm, this is what I will have. And if I'm going from dorm side to student side, it says multiple, so the relationship is many, so this is what I will have. And at the end, I will have something like student, and then dorm, and I will have my relationship in here. And we said from student to dorm, it's going to be a bar, and from dorm to student is going to be the crowfoot. And then I will just say lives in. You don't have to specify what's in the bottom. We can just always infer it from what's on the top. And this is our final ERD. Another example, a student can buy multiple books, and a book can be bought by multiple students. Again, if we do our simple analysis here, we'll say, okay, from student to book, and then we'll have from book to student. From student to book, a student can buy multiple books. So this is a many relationship. And from book to student, again, we also have a multiple keyword, which is a many relationship. So we will have something like this, student, and then books here, and we'll have many on this side and many on this side, and we'll just say can buy or buys. And this is going to be our final ARD. Again, keep in mind that I didn't include the labels here, but we will have to include the label. So I will say something like lives in on top here, and I will say something like buys or can buy on here. Okay,